So in our module number 4, we'll be focusing on packages and multi-threading. We'll understand the concept of packages and we'll see how we can write the packages, and then we also have something known as exception handling techniques available in our programs. So John is conducting a training session for the freshers in the company. He's supposed to lead it. So he's gonna come up and he's gonna teach and share his knowledge. So he's gonna come up with the interfaces. So interface is something which will have specifications, some rules defined within it, and the interfaces can be adopted by the objects for which they need to come up with the definition part. So interface has set of method declarations which are known as specifications, and you need to override the same part. So why are interfaces used? Interfaces are used so that implementation can come into action for some system behavior. So a class can extend one class, but interfaces can be implemented in a multiple fashion. Multiple inheritance is not supported, but multiple implementation is supported in Java. So that's different now. So your interface, if it is having n number of methods, so all the methods will be by default public and abstract, and all these methods, they are supposed to be implemented by the class. Now that's like you got the rules. So where and all we can write interfaces. So when you need to come up with some common functionality and you identify the need of runtime polymorphism, you come up with the interfaces. For example, in banking, deposit and withdraw will be same for any type of bank account. So for any account, either it's a savings account or a current account or any kind of an account, it must implement one interface known as transaction, which will have deposit and withdraw as methods. So here is one program on interface. We got interface area, which has a method which is being implemented by the class rectangle. Then we got interfaces where we can define the attributes. So attributes in the interfaces, they will behave like final variables, or they are by default final variables whose value cannot be changed. So what is a final variable? It's a variable whose value cannot be modified. Interfaces can be extended as well. So you can extend interfaces in a multiple fashion. So one interface can extend one interface, or one interface can extend multiple interfaces as well, but this is not kind of multiple inheritance and on an object level. This is the kind of a multiple inheritance on class level. Interface level, we'll say it separately now. So let us understand what is meant by the word package. Package is nothing, it's a directory or it's a folder in your programs, right? So here we can group some similar classes all together in a single package. So we won't have any naming conflict, and we get something known as to define the access types with package. So package means now you need to come up and understand what is meant by the term access. So package in Java is a folder or a directory through which we can organize Java classes as namespaces. So programmers can use package to organize classes which belongs to the same category. Other than that, classes in same package can access each other's package access member. So we'll understand this statement. Now packages in Java, so they come with the lowercase. So you write the names for your packages in the lowercase. And basically it starts with the reversing the domain name. For example, if the domain name is example.com, then the package name becomes like com.example. Your application name. So that's how we got the naming convention. So the naming convention is followed for some more of the packaging names. For example, you got the domain name, your package name becomes the reverse of it. You got some hyphenated name.example.org, so you use it like an underscore. Then example.int, let's say we got some data type, so you can come up with the underscore.example. Similarly, if your domain starts with some number, you can do it in a reverse way with some underscore so that you can use it off. So packages in Java, let us see practical part of it. So within my src, I'm gonna do a right click and I'm gonna create a new package. So this package comes like co.edureka.1. Let us say a finish on it. how to create a package. Do a right click on src and say a new and then say a package. So you're gonna say co.edureka.2. So all in lowercase. So you can write package of your choice. So I'm just gonna do this packaging. So let's come back to the directory structure. You can see src contains co.edureka.1 and 2, which is all empty now. So in the bin folder, we do have this guy known as co.edureka.1 and 2, which is empty. It means these packages are created in two levels. So level number 1 goes with the src. Level number 2 goes in the bin folder for the bytecode. So in my one package, I'm going to come up and say a class as 1. So it has the no main method. In my package 2, I'm gonna create one class. Here I'm gonna say the name goes like client with the main method. So both of these classes, if you can see the Java file that is created in these folders, and one.java contains one added instruction package co.edureka.1. Similarly, client says package co.edureka.2. It means that when you compile the source code, the byte code of this client class shall reside in the package 2. So 1 contains one.class, 2 contains client.class. Over here in the source, 1 is one.java and 2 is client.java. So the symmetry is being maintained now. Now in my one.java, I'm going to come up and I'm going to write one more class as 2. And now you see we got the same source file one.java, but in the bytecode you will find that we got 1 and 2. So one directory contains two bytecodes. One is one.class, another one is two.class. Now let us start exploring the concepts. So class 1 is public. Class 2 has written nothing in front of it. We got this class as a public class and this class as a default class. So default means you write nothing. So if you try to come up and say some class like a private class 3, so this is an error, right? So class cannot be private. Similarly, if you try to say this guy as protected, so a class cannot be protected also. You cannot create a private class or you cannot create a protected class. So this is not allowed. So Java, we can have two types of classes. That's like either a public or a default. That's the study number 1. So if I try to say one more concept over here as public class 5, so you will see now this is again an error. And when I say class as 6, so this class 6 is not an error. It means in one source file you can have only one public class. You cannot have more than one public class. So if you are writing the Java source, in the Java source we can have only one public class. You cannot have more than one public class. If you make a class as public, then the source file should have the same name one as that of class name. So here we are getting an error that this class is public, so the source name should be 5.java. So if you make the source name to rename as 5.java, this error will be gone, but error will start coming over here that the class name is 1 which is public, so file should be 1.java. So one source file means only one public class. So only one public class and can have multiple default classes in one source. So we are saying in one source file. So please understand this concept. Coming up to the next point which we are discussing over here is that class which is marked as public should be saved in the same name as in the class name 1.java. So you can't have two public classes. So now we are coming and understanding a point where we are supposed to say the term private, default, protected and public. In order to understand these 4 access modifiers, so these are the what? These are known as access modifiers. We will now understand these 4 access modifiers out here. So in my 1.java, in both the classes 1 and 2, 1 is public. If you write nothing, so 2 becomes default. I will write 4 methods. The very first method is private void pvt show. So I'm gonna say CSO. This is a private show of 1. Similarly, I'm gonna come down and I'm gonna write the other methods. So this guy becomes default, this guy will become protected, and lastly you're gonna come up with a public guy. I'm just gonna change the name. So this is public, this is protected, and this is the default. So I'm gonna say as in default show, then you say protected show, and lastly you're gonna say the public show. So 1 is public, which contains 4 different methods with all the access modifiers. 2 is default, it contains all the methods with all the access modifiers. So 1 and 2 classes available in the 1 package. So what is the hierarchy now? What is the structure? Let us see that part. So what we have this package over here. So we got the package as 1. So this is the package which is named as 1, and we got one more package which is named as 2. So I got class 1, class 2 in the package co.edureka.1. If you can notice this, 1 contains 2 bytecodes, now rather 3 bytecodes, 1.class, 6.class, and 2.class. So we got 3 guys. Let us understand. So we got 1, 2, and 6, but I'm just coming up with 1 and 2. So we got a class 1 and we got a class. So what is the difference now? The difference is that this guy is public, whereas this guy is default. So 1 contains 4 methods, which is like private, default, protected, and public. Same is available within the 2. In my package 2, I have another class which is known as client. So this client is having something known as main method. So client has the main method. So this guy is having the main method. What is accessible outside the package? 1 is accessible outside the package. So we must understand this guy 1 is accessible outside the package. But when you talk about the class 2, which is default, so this guy over here is not accessible outside the package. The first difference which we are bringing is the difference between public and default. So public is the one which is accessible outside the package. Default is the one which is not accessible outside the package. Let us see this part now. In my client, I am going to write one instruction which is like import co.edureka.1.1. So now you can see there is one instruction known as import, which means that to include one dot class from the other package into the 2 package, so that I can come down over here and I can write the objects of 1. But at the same time, if I try to say import co.edureka.1.2, this is an error. So why it is an error? Because 2 is not visible, it is default. So defaults are not imported. It's an error. So what you can import is only public. And the next point which we must understand is the class 1 is public, class 2 is default. You cannot have a private class, you cannot have a protected class. It means if you want your class to be imported by the other package in some other package, that has to be public. So it's very basic to understand. If a class is public, it is accessible outside the package. If class is default, it is not accessible outside the package. So These are only the two simple statements which we need to understand. So nothing is complication over here. So one is public, which is importable. Two is default, which is not importable. We have seen this part now. So if you come up in the package which is 2, so you are in the 2 package. So here we are in the 2 package. In the package 2, 1 is importable, but 2 is not importable, not accessible outside the package. So default class we cannot access outside the package, whereas public class can be accessed. Other than that, classes, they cannot be private or they cannot be protected. So it makes no sense of coming out with the classes as private or protected. So now in my client, I'm going to say o.pvt show. So this is an error. When I say o.default show, this is again an error. When I say let us say protected show, it's again an error. Then if you say o.public show, only public show is accessible. It means that the private, default and protected, they cannot be accessed outside the package 1, even though the class is public. So only one guy is accessible. So that's like your public. So they are not accessible. So private says I am accessible only within this container. Default says I am accessible within the container and outside some other container as well. Let us understand. Private remains only within this region 1, only within this class. Default only within the package. Public within the package, outside the package. So private only within class or object. Default only within package. Protected also within the package, and public within or outside the package. So it means that we are coming up and understanding that private is the only one guy, so which is on a class or an object scope. So this scope is limited to the class. So private says my scope is limited to the class or object. Default says that my scope is limited within a package. Protected also says the same story, what default says. Public says I am most accessible. So what is the difference between default and protected? So this guy is inheritable outside the package, whereas this guy is not inheritable outside the package. So looking on to this structure now, we can see that you cannot access something known as private, default or protected outside the package. So that's how you can see the errors came in. Now what we must understand over here is that if there is some class over here, let us say class as in child, which is supposed to inherit 1. So child is inheriting 1. So it means that you can say child ch assign new child, and then you can come up with same 4 method calls. So let us try to come up with the same method calls. So here you got ch. Now you can again see that with the child you are unable to access these 3 methods. It means that they are not available in the child object. Neither private is inherited within the package nor outside the package. Default can be inherited within the package, not outside the package. Protected can be inherited within the package as well as outside the package. But when it is inherited outside the package, this behaves like private. So inherited in child but behaves like private. So what we can do, we can write down a method over here. For example, let's say a fun, and within the fun method you can call this guy known as protected show. So protected show is inherited outside the package, but it behaves like private when it's inherited. So private show is not inherited and default show is also not inherited, if you can see. So we are not getting these 2 methods inherited, but protected show is inherited. That's why I am able to access protected show in the fun of child. Since this is private, it's behaving as private once it is inherited. That's why I'm going to come up and say ch.fun. So fun will indirectly access the protected functionality. So in the conclusion part, what is what? So in the conclusion part, we must understand private is not dealing with the packages at all. Private is only dealing with the class or the object. Default is only dealing with the package, not outside the package. Either it is the class or it is any attribute or method within the class. So that's like we got the default. Protected is also same as default. The only one difference is that this guy is not accessible outside the package but inheritable outside the package, and the moment it gets inherited it will start behaving like private. Lastly, we got public, which says I don't care, I will be there in the package, outside the package, I'm accessible throughout the world. So let us now proceed. Packages are used so that you can group some classes all together. So it is modularity which has been increased. So you can also use import with the star so that you can import all the classes in a one single shot. You can say like dot star. So it's gonna import all the classes. So what will be imported? Only the classes which are public. So that also you must understand. So moving ahead now. So this is how you come up and create the package. So co.edureka.pack1 with the company domain. It's more professional now. So any static functionality which you need to import, you need to come up and say import static. There might be a static import as well which you can do. So this is one more program on package. So we got a class and gonna import this class package in some other package and you can use it off. So the way we have done. So these are the 4 access modifiers which are used inline to something known as packages. One is public, other one is private, protected, and the default. So what and all these guys are? These are referred to as access modifiers in object-oriented programming structure of Java. These 4 modifiers, they work in different domains now. So public can be accessed within the package. It is inheritable outside the package. So it's like full-on accessibility, visible truly to anyone, to anywhere. When you talk about protected, it is not visible outside the package. It is inheritable outside the package. It is also accessible within the package. So that's the only one term, inheritable. When I'm going to come up with the private guy, so private guy is neither accessible within the package nor accessible outside the package. It is only accessible within its boundary or the region of class. Lastly, when you got something known as default, it is accessible within the class, within the package, not accessible outside, not inheritable outside. So this is one access level. So public, protected, no modifier means default and private. So within the class they are accessible. Within the package, yes, this is not within the package. Within the subclass, yes. So these two guys are not accessible within the subclass. So if you talk about the world, so public is accessible, all of them are not accessible. So world means outside the package now. So here we got this package means default, because you will be developing the projects. So the next discussion is about exceptions. So what exactly is the term exception now? So let us understand and get the meaning of exception. Let us say you got some static part in your class, so you want to import that, or you want to use some static functionality, so you need to come up with a static import somehow. What next is something which we need to study. So I'm gonna come up with a new class, and now here itself I'm gonna say exe demo with the main method. So I'll come down with the package as co.edureka.exceptions. So let us say co.edureka.exceptions. So you say finish. So you get the package name as well the class within the same one go. So I'm gonna say CISO main started, and in the end I'm gonna say main finished. So let us write one basic program. I'm gonna say an array with some values 10, 20, 30, 40 and 50. So thereafter I'm gonna say CISO ARR of 2 is plus ARR of 2. So what I have done over here, so I just came up with one very basic program, if you can see now. So we started the main and we created one array, and then we have just printed out the array and then we said main finished. So what is happening out here now? When you run the code, your main starts, your statement for arrays they executed, and your main is thereafter finished. It's a very basic program where what we see is that all instructions in the main are executed step by step. So they are executed step by step and program finishes gracefully. It starts and it's finished. So it's like what we got as in the flow. Now consider one more flow where I'm gonna say ARR of 20. Now first thing which we need to understand is ARR 20 is not existing. So point number one. So ARR 20 is not existing. But even though ARR 20 is not existing, my compiler is not giving me an error. So compiler is not prompting. So that is what we are getting. So ARR 20 is not existing. At the same time, we got compiler not prompting us with this error because arrays are created at runtime, right? So that's why it is not prompting us the error. When now I run the code, I see main did start, but main never finished. So what is the result of this instruction? So ARR of 20 is resulting in an error at runtime. So it's resulting in an error at runtime. So what is the outcome of this guy? So program crashes and main is not finished. So it's not the graceful execution of a program. So the program just crashed off for us. You can say it's an abnormal termination. Let us say we got some class over here which is like some my maths. So let us say we got this class like my maths where you are having one function like some add which will do some addition part. So I'm supposed to come down and I'm supposed to say my maths mmsi new my maths, and I'm supposed to do mm.add. So I'm supposed to add. So when I will add the numbers, so it's gonna come up and give me the result. So let's say A and B. So it's gonna say sum is plus, you just add the numbers A and B. So I'm gonna pass 10, 20. You will find that nothing happens after this crash. So if the crash is not there, so everything written in the main is executed and you get the graceful termination of a program. But at the same time, when there is some statement due to which the error occurs at runtime, your program is simply crashed off. So when the program crashes, your software dies. So what is happening over here? Your software is terminating abnormally. Now this error at runtime which crashes your program is known as exception. This error is known as exception over here. So an exception is a state by which whenever it's gonna occur, so it's gonna disrupt the normal flow of the program. We have various exceptions available in our Java, right? To name a few, we got arithmetic exception, array index out of bounds exception, null pointer exception. So these are some of the errors which can occur at runtime. So what is the solution to this problem now? So the solution to this problem is you number one identify the line where the exception is coming. It says line number 18. So this message is coming up implicitly to you. extdemo.java line number 18. So this is your line number 18. What is the name of the exception? It's like java.lang.arrayIndex out of bounds exception. So java.lang is the default package. So the class name is array index out of bounds exception. So what is happening over here? So whenever you do something abnormal at runtime, so what system will do? System, that's like runtime environment, JVM, will create the object of array index out of bounds exception class, and it's gonna throw that object. So the moment your object is thrown, so the program is crashed, you need to catch this exception object so that your program is not crashed. So what we'll do? Produce something known as try and catch. So the statement in which the exception can come, put it in try. Within the catch, you mention the reference to the array index out of bounds exception. I'm just coming up with this class name, and this is the reference variable which I have created. And then you say CISO some exception, and then you can say plus a ref. I'm just printing out the reference variable. Now when I'm going to run the code, I see that main started some exception, that's like my message, with a ref giving us the output as in it's an array index out of bounds exception due to the guy 20. Sum is 30, main finished. The same program written with one try catch allow our program to catch the object of array index out of bounds exception in array. So this is the way by which you are coming up and you are saving your program to not go into a state of crash. So that's like one of the most bad and awkward situations when your program's gonna die. So now considering one more statement, so let us say you got one number A which is 10, one number B which is, let us say 2, you come up with C as A by B, right? So you got this number C which is A by B, and you say C, so C is plus C. When you're gonna run the code, you will find that you're getting the value of C as 5. We would get an exception, but we handled it. Let us say this guy is 0. Now this guy has turned out to be 0. When you run the code, you find that exception came in. Wherever the exception will come, exactly below this instruction, nothing will be executed. Even though you got a try catch below, but the moment you run the code, main starts off, but at the line number 19, where you are getting the exception, so what we can see that it is not getting executed below that. So what I can do now, I can just take these statements and I will put them in my try block. So when I put them in my try block, I run the code again, I'll find the exception again, because I got a catch which is catching array index bounds exception, not the type of exception which is thrown by this operation. So that's like arithmetic operation. So what I will do, I will come up and I will write one more catch where I will define this guy known as arithmetic exception, and I will write again some exception and I will just print out the guy AE. So that's how you're gonna come up now. So now when you run the code, you will find that your arithmetic exception came in and now the code is running fine. So considering that we can have multiple exceptions, we can write either the separate try catch blocks, or you can combine and you can write try with the multiple catch blocks. There can be a situation when you are writing a statement which must be executed. Now when you are coming up with this must be executed statement and I'm going to run the code, you find that it is not getting executed somehow. Why? Because when the exception came in this line number 24, control directly transferred from this try block into the catch block, and the underlying instructions within the try are not executed now. That is also one more point which we must understand. So when you are putting up this try block, wherever the exception in try will come, so below that no statement will be executed. Even though I'm printing ARR2, if you can see now, I'm just printing my ARR2, not ARR20. So the moment you get the exception over here, so these statements are not printed. So that's the behavior now. So we must come up and we must write one more block known as finally block, where all the instructions which must be executed should be kept. So finally is a piece of block which will be executed regardless exception comes or exception do not comes. So even though you are able to handle the exceptions, but in the try block there might be some statements which cannot be executed when the exception will come. So what we can do, we can come up with try catch finally is that block where you can write the statements which must be executed. I am going to come up and introduce you to something known as the types of exception. So now what exactly an exception is, when we know that part, so exception can be divided into three parts. The first part is checked exceptions. So here we are talking about the exceptions which compiler will check. What is meant by compiler checking your exceptions? So compiler will check your exceptions and compiler will prompt us to put the code into try catch block, else he will not allow you to resume. So what I'm trying to come up is, let us say I'm going to write one basic instruction over here. So that's like thread.sleep. So now this is one instruction. So you can see compiler is giving an error, and this error says unhandled exception type interrupted exception. So what I'm gonna do, I'm just gonna click on this and I'm gonna say surround with try catch. So when I am going to get an error prompted by the compiler to put your code in try catch block, so which exception is being handled over here is known as interrupted exception. Such an exception is known as checked exception. We are just classifying what is a checked exception. For checked exception, your compiler will come and it will give you the error and it will tell you to put your code in try catch. So that's how you need to come up and define the checked exceptions. Then we got runtime exceptions or unchecked exceptions. So these are known as unchecked exceptions. So here the compiler is not gonna come up and check. So if your exceptions are going to come in the program, so there can be two types of exception. Either it can be checked or it can be unchecked, which is known as either runtime or unchecked. So runtime exceptions or unchecked exceptions are the one which will not be prompted by the compiler, and hence they will finally make your program to go crash. Unchecked exceptions are the direct subclasses of runtime exception class. So we also got a third guy known as error. So what is this error all about? This error is also supposed to come at runtime, but it is morely associated with the memory part. For example, if your stack is full, stack's gonna overflow. So this is the kind of error from where the user cannot recover. So you cannot recover from errors, but you can recover from checked or unchecked exceptions using the try catch blocks. Now let us see the hierarchy of the exceptions. So we can closely understand that the exception class, which is the direct child of throwable, and error is sibling to exception, whereas exception is divided into two categories now. One is the runtime exception, other one is the IO exception, SQL exception, and other exceptions. So any exception which belongs to the runtime exception, so all these exceptions belongs to the runtime. So arithmetic exception, array index out of bound, null pointer, all these exceptions, security exception and other exceptions, so they are nothing but they are the children of runtime exception. So exception has two types of children now. So your exception is one class in Java which has this guy known as runtime exception, and the other ones like IO exception, SQL exception, then something like interrupted exception, and many more. So these four are the children of exception. Child of exception, child of exception, child of exception, and child of exception. I can say each and every guy is the child of exception. So I can then say exception is the parent
of all the exceptions. So whether they are checked or unchecked. So we don't care whether the exception is checked or unchecked in a way to understand that both the exceptions, they are the direct children of exception. So runtime exception means unchecked exceptions. Other than the runtime exceptions, all exceptions are checked. So I'll just mention other than runtime exceptions, all exceptions are checked. So it means IO exception is a checked exception, SQL exception is a checked exception, interrupted exception is also a checked exception. So runtime exception has many children now. So all of them, they are unchecked. For example, you got null pointer exception, you got arithmetic exception, you got number format exception, you got, let us say this guy, so array index out of bounds exception. There are so many unchecked exceptions. The problem is how we will identify and how we should come up to know that which exception has to be put in the catch block. So we'll use the fundamental of polymorphism over here. What does polymorphism say? It says that parent's reference can point to the object of child. Now that's what the polymorphism says as in a polymorphic statement. It means that I can clearly write exception as in E, which points to a new null pointer exception. E is pointing to a null pointer exception. E can also point to an arithmetic exception. E can also point to a new of IO exception. It means that so you need not to come up and remember each and every different name. Rather, coming back over here in your program, you need not to come up with the multiple catches. You write a single catch and you just say exception E, and then you can say CISO message is plus E. Message for exception is plus the E. So it means that whether the object of array index out of bounds exception is thrown by the runtime environment or the arithmetic exception, your alone exception will be able to handle anything now. So the program is executed in a proper way. Let us say this guy goes 0. Your program crashes and it gives you the java.lang.arithmetic exception, even though this guy is exception. So if this is not a case, if the case goes like that your array has a problem, when you run the code back, so let us change this guy to 5. Now you can see the same guy is also handling the array index out of bounds exception. So it means you need not to worry about knowing which class or what exactly is the type of exception, because the same exception can handle your multiple exceptions, highlighting the concept of runtime polymorphism. So this one as an exception can be used to come up with both the different types of exceptions now. So why exception handling? When you will get the error in your program, you must handle it not the compile time but the runtime. So you need to come up with a try catch block as a solution. Then exception handling says that in case your program is supposed to have a runtime error through which you're gonna get a crash, so issues can be resolved using the exception handling technique, where mainly try, catch, and finally will be in action. So these are kind of important keywords to perform exception handling. So try is the block where you must write the statements which can produce a runtime exception. Then catch will handle these runtime exceptions, but you need to mention the corresponding reference variable, or you can come down with the exception concept, runtime polymorphism. Then finally is that block which will be executed regardless of your exception is going to come or not. So why to write finally? Finally is written so that you can release the resources and you can just do some memory cleanup or so. So in the finally part. So one try can have multiple catch blocks. So this is also possible now. So it depends upon what is the type. And if you want to come up with a runtime polymorphism concept, you can also write down a single class known as exception. and you can get its any reference variable of your choice. So now this can catch any exception. So try can have multiple catches, but you can reduce your multiple catches with one single catch. That's like your exception E. Then try catches can be nested also. So you can have try catch within the try catch. You can have a try catch within the catch. You can have try catch within the finally even. So this nesting can go up to any level. For example, over here, so what we can do, so we can come down and we can just write these two instructions in one try catch, and you can just take out as an exception E. You can also use E dot print stack trace. So when you use E dot print stack trace, so this method will print all the stack from where exception originated. So it's gonna print all the stack trace where the exception will originate. For example, let us say we're gonna mark this guy as 0. So first of all, this exception will come and then you're gonna get execution for this guy. So you will now see that it says arithmetic exception divide by 0. So this is known as a stack trace. It is going to tell you which file over here and which is the line number where this exception originated. So that's why developers can use print stack trace so that they can come to know in which file they will be getting the exceptions. So that is what the definition and the use of print stack trace. Try catches can be nested depending upon the requirement. So the next is the keyword throw. So let us understand, when we write a program, exceptions are the errors which occur at runtime. So who's gonna come up with this errors? I'll say who will generate or throw an exception. So the answer is JVM. Your Java virtual machine, this is going to come up and throw you an exception. So you must understand that JVM or the runtime environment is the one who is creating this exception and throwing it. You yourself in the program can throw the exception. By user is possible by the use of throw keyword. So you can also throw an exception, but you need to use the keyword known as throw. Now, how many different types of exception you can throw? So you can throw number 1, unchecked exception, number 2, a checked exception. There are two categories to the exceptions now. So for checked exception, compiler will give us an error to put the problematic code in try catch. But here compiler will not prompt. So here compiler will not prompt. So that is one definition which will distinguish between unchecked and checked exception. Thereafter, we must understand runtime exceptions are unchecked, whereas all other than the runtime exception are checked. So one is you are just classifying, so what are checked and what are unchecked. Another thing is you are defining how the checked and unchecked are. There might be a scenario that what we are doing, we are writing a try catch. So I'm going to say a try and I'm going to say a catch. So now I'm justifying that this catch can only be a null pointer exception. But here somehow you are writing the code like A by B. So you are not catching an arithmetic exception, but you are catching some null pointer exception. It means that even though you have a try catch block, but the exception which you are planning to handle is not handled, and hence your program crashes from here itself. So point is really important to understand. Even though you have a try catch, but you don't handle the exception, your program is crashed. It means that if I have this try catch within one try, so let us say you got try catch within a try and you got some more try catch. So here exactly your some different logic works, and you got this catch coming in over here, and here also your catch is not handling. So here it is array index out of bounds exception. So now when the exception is thrown here, so if the internal try-catch block is not able to handle it, the external catch block will try to handle it. Even if external catch block is not able to handle it, then your program's gonna crash off. So that's how you must understand, if something goes fishy in this try, that will be handled by the catch. So now let us try to come back and understand what is meant by the throw keyword. So throw is used so that you can crash your program. For example, let us talk about two scenarios. So in a case of voting for the softwares, so if someone's gonna vote with the minimum age of 18, obviously you can give a message to the user that your age is not suitable to vote. But let us say user is trying again and again and again. So he's just trying to mess up the system. So what you can do, you can just crash the program by checking if the guy's age is less than 18, and even though he's trying to come up and redo the voting procedure, so you just throw an exception and you crash your program. Similarly, in the banking application, if the customer account is blocked or closed and bank's gonna get the check to clear the amount, so again you can throw an exception and you can tell that it is not possible. So throwing an exception is possible with the keyword known as throw. Let us understand how you can throw an exception. So let us write one new Java project, and I'm going to name it like session number 7. Let us write one new class. So I'm going to name it like throw demo. So let us take the package like co.edureka.exceptions, and throw demo has a main method somehow. So here we are. I'm going to write one class which is like banking now. We got a banking class. I'll write one function known as void withdraw. So I'm gonna say withdraw. So what amount you want to withdraw, you can mention that. And you got one balance in your account which is like 10,000. That's how you're gonna come up with the balance part. So what I'm gonna do, I'm gonna check one difference by saying balance minus amount. So if your difference is coming out to be less than, let us say 5,000, then this is a problem. Else you say balance assign balance minus the amount, and then you can come down and you can say CISO amount is withdrawn and balance is plus the balance. So you can just come up with balances, let us say backslash U20B9. We'll see what happens now, right? So guys, I got a very basic structure coming in for the class banking, where you got a balance of 10,000, and if your difference is less than 5,000, so I need to crash my program. So I just want to crash my program if the balance is 5,000. So let us say there is a banking, be assigned new banking. So we got a customer to the banking, so we are going to give him a banking object. So a customer can do a withdraw now. For example, for the first time, it's gonna do a withdraw of, let us say 2,000. Second time also is gonna withdraw 2,000. Third time he's gonna withdraw, let us say 3,000. So when I'm gonna run the code, so here I'll just say a CISO on, balance is low. So let us run the code and see what happens now. So you can see that for the first 2 times, we get the program coming up in a proper way, but for the third transaction, so 6 minus 3, it goes below minimum amount. So this is like minimum balance to be maintained, that's like 5,000. So we are throwing user an error that balance is low. What I don't want the balance low coming in, I want my program to crash. So my program to crash means what? It means that, so here you are like main started. So I'll say, rather than the main, I'll just come up and I'll say banking started. In the end, we'll have banking finished. So when you run the code, you get this complete program executed. Let us say you come down here and you say throw a new null pointer exception. You created the object of null pointer exception and you are throwing it. So let us not get confused. you say null pointer exception, np assign new null pointer exception, and then you say throw a null pointer exception. So you don't want to give the user a basic message. You want the program to be crashed. Now you can see banking started, but the banking didn't finish. So the program is crashed over here. So what is the exception which you are throwing as of now? So what is this kind of an exception? I need to crash my program. So we are throwing an unchecked exception. You can also provide a message over here that balance is low. Now when you run the code again, you find that your code is crashing, and here you are getting the message also balance is low. Now my next concern is not to throw a null pointer exception, not to throw an unchecked exception, but now I would like to throw a checked exception. Let us see what happens now when you throw a checked exception. Let us say throwing a checked exception. So for checked exception, I'm going to come up with the IO exception. So that's like IO exception. So it's from the java.io package. You say IO exception, IO assign new of IO exception. So same thing in the constructor, you say balance is low. But the moment you use the keyword throw IO, you get an error. This is something which we need to understand. This is something where you are getting an error. It says unhandled type of exception over here. So what you do, you can just put one signature over here as in throws IO exception. When you throw any checked exception, so you come up with the keyword known as throws in your method signature. So throws is a keyword. Use it when you are throwing a checked exception. Compiler was giving us the error over here. So that's why we appended this instruction. So compiler will prompt you for the checked exception. Now the second thing, you can see that you are saying banking.withdraw, banking.withdraw, and banking.withdraw. So all these three function calls, compiler is giving an error. Previously he was not giving an error, but now he's giving an error. Why? Because compiler says that put it in the try catch block. So you say any exception over here, we'll be handling that part. We'll say CISO exception is +E. So now you can see there is no error which is being coming in. So if you are invoking a method, so if a method is invoked which throws a checked exception, compiler will prompt to put it in a try catch. Now that's what we got the property for the checked exception. So now when you run the code, so you will find that you're getting an IO exception which says that balance is low. So eventually we must understand whatever the type of exception we are throwing is not justified. So you are throwing IO exception, you are throwing null pointer exception, and you are doing the banking. What I can do, I can just come up and say class banking exception can directly extends exception. So this is known as user defined exception. You are defining the exception. So banking exception is one class which extends a predefined class like exception. And now what I'm gonna do, I'm just gonna come down with the constructor of banking exception where I will take some input as some message which I will just pass it to my superclass. So now rather than coming up and creating the object of checked exception, throw user defined exception. So how you can do that? You just come up with a banking exception, be assign new of banking exception. For the message, you can just say balance is low, and then you say throw of BE. So now compiler will give you an error because you need to come up and say throws banking exception. And below, if you can see, you got your same guy exception. We don't care what is the type of exception, but we'll handle everyone. Now when you run the code, you find that exception which was thrown is code.edureka.exceptions.banking exception. which is more relevant as compared to any null pointer or IO exception. So if you want to come up with an unchecked exception class, you can directly say extends runtime exception. In case you want to come up with the unchecked exceptions, you can come up like this. So for unchecked exception, if you want to write a user defined exception which should be unchecked, create it as a child of runtime exception. If you want to create a checked exception, create it as a child of exception. So that's how you can come up with something known as checked and unchecked. When you throw a checked exception, you need to put the keyword throws with the method signature. Compiler prompts you that, but when you are throwing an unchecked exception, you need not to put that. Secondly, for throwing an unchecked exception, you need not to put your statements in try catch. But if you are throwing a checked exception, compiler will prompt you to put the method calls in the try catch. Throw is one keyword with the help of which you can write your exception and you can throw it. Throws comes in the signature of your method. It is required when you are going to throw a checked exception. You can also use the throws keyword coming up with the multiple exceptions. So it's not like a method can throw only single exception, a method can throw multiple exceptions. If you write throws exception, you are done with every exception now. So your method can throw any type of exception. So now we'll be discussing what is meant by program versus process versus thread. So let's proceed with the next topic, multi-threading coming into the picture now. So before we proceed with what exactly a thread is, we must understand a difference between program versus process versus thread. Program is set of code which you are writing. So now the program is set of instructions which you write, and now this gets stored as in bytecode or as in binary form into your secondary storage, and whenever you need to execute it, it is loaded into the kernel by the operating system, and then it's gonna execute the program. Now executing instance of a program is called a process or a task. When we talk about a program, let us try to write a very basic program. So I'm gonna come up with new class and I'm gonna name it like threads demo, with the package name coming out to be, let us say, threads, along with the main method, and then you say finish. So this is one program. So the program says main started, and in the end it says main finished. So few instructions in the program, they are written. So in between, what I'm gonna do, I'm just gonna come out with for int I equal to 1, I less than equal to 10, and let us say I plus plus. So I'm just gonna say CISO main. So when I will run the code, there is one thing which I must understand, that program is getting executed sequentially. First of all, main started, then the loop executed, and then the main finished. So it's a sequence concept now. For the program, you got the bytecode. So when your program is going to be executed, what will happen? OS will create a process. So here we are with the process now. So what happens in the process? In the process, we get the main thread. Your running program is called a process. So this is the thread, specifically known as main thread. So main thread will have some jobs which it's gonna perform. So we can say that these jobs can be some small jobs or they can be kind of some proper jobs. So let us say these are the jobs which main thread has to perform. So consider that there has to be some bigger job which has to be performed by the main thread. So these are all the jobs are performed by the main thread in the process, and jobs are mentioned in the main method for the main thread. Very, very important when you are talking about something known as a main thread. OS will run the program, the moment the program is executed, your OS will create the process. Process will have a main thread which will perform this set of instructions sequentially, and all these set of instructions, which are nothing but which are the different jobs, they are going to be performed by the main thread, and you write the code in the main method. So you can say that the instructions which we are writing over here, they belong to the main thread. So you can say main thread started and main thread finished. So whichever the output you are able to see, that is nothing but that is the main thread getting its tasks executed one after the another. So if this guy is the first task and this guy is the nth task, so the tasks are executed in a sequence from 1 to n. So how they are going to get executed? They are going to get executed in the sequence from 1 to n. So that's how they're going to get executed. Now, there might be a scenario that there exists some heavier task. So this task is a bit more heavier, if you can see. So this task will, or this job or this instruction is supposed to be a blocker for the underlying guys. So if this is getting executed until this is not finished, these instructions will not be executed. Let us see that example. So I'm going to create a class known as task. So there is some task. So I'm going to write some method known as execute task. So this is supposed to come up, and let's have a loop over here. This task over here is executed, and I'm just gonna come up with the printing of I. Same, let us try to come up and print the I over here. Now your main thread has main thread started, then this task for the main thread or the job for the main thread, and then finally this task for the main thread. So what I'm gonna do, I'm gonna create a task t assign new task, and then you say t dot execute the task. So we must understand this function will take 10 instructions to be executed before these tasks can execute. So until your task is not finished, below instructions in the main thread, they will not be executed. So we are trying to understand this guy is a blocker for these two guys. So in a particular thread, there might be a blocker task for some other tasks. If this blocker task is a very big blocker, let us say we are going to fetch the data from the network now. So it means that these two threads, they will be blocked, and if your main thread is blocked for some reason, your OS will give you a message, would you like to wait or would you like to kill this application? So we must manage the performance of your application. So what we can do, we can bring up one more guy just parallel to the main thread. You come up with one more thread known as a user thread or a child thread. You say this guy is a user thread or a child thread. Whatever the name you want to give it, you can give that part. So we will offload this heavier task to this guy. So you offload the heavier task to this guy. Thereafter, you come down and you write one small instruction to get this guy started. So you start one more guy. Now the difference is these two guys will be executed parallelly. So let us say that if your user thread is having some more instructions now other than the heavier task. So now these two threads, they will be executed parallelly, not sequentially. So what I'm going to come up and understand is that as of now we can see this task is executed in a sequential manner. It means that you get to see the output of this guy, then your control returns back. So now if you create a user thread, so these tasks will be executed parallelly. How? CPU will perform time slicing now. So it's gonna give some time to the main thread and then some time to the user thread. Then again, it's gonna switch back to the main, switch back to the user. So it's gonna switch it and it's gonna execute both the threads parallelly. You need parallel programming so that your overall performance of the system might increase. Let us take an example now. So there is a wedding event at home. For the wedding event at home, let us say father has to prepare all the arrangements. So now father has to do what? So he has to come up and he has to see for the caterer. Then he has to see for some DJing or the music. Then he has to come up and finalize the venue part. So he is having lot of other, you can say, responsibilities to fulfill. Now, let's say day one, he's out and he's gonna, finalize the venue for the day. So he's moving and he's searching for the venues, but until and unless he do not finalize the venue, he cannot move on to the next guy known as finalizing the caterer. So since he's alone now, he has to manage it. So this is something where if venue is not getting finalized, so caterer task is blocked until and unless this venue is not finalized. So what he has to do? He has to bring some external help. He has to bring out some of his relation to help him up. So parallelly, let's say he's gonna call his brother that you search for the caterer and I'll search for the venue. So these two guys are able to search and finalize the venue and the caterer parallelly on the same day. Why we need user thread? So that we can offload some long running tasks to the child thread and both the threads will thereafter run parallelly. So multi-threading is a concept which comes in the process. So on a computer, on the operating system, multi-processing happens. That's like you can execute so many different programs. For example, music player, internet browsing, playing the game, some notepad. So all of these are different softwares which are running all together on the same computer. So they possess multi-processing. But if you talk of any one single application like music player, one single process, so it's playing the songs, downloading the updates, managing the playlist, so all these actions can be done parallelly. So this is what we call as in multi-threading technique in a process. So coming to the multi-threading part, so how we can come up with the multi-threading? Thread is a task to be performed and multi-threading is multiple tasks getting executed at the same time. So that's like the parallel programming or the concurrent programming. So multi-threading will take the same memory space. So it means that memory is not wasted, it is utilized somehow. So what are the advantages if we implement multi-threading in a program? Number one, you need to identify why you need multi-threading. You need multi-threading for the long running operations. So multiple processes or tasks, they're going to run at the same time and hence they will save time and they're going to save the speed. Other than that, running two different programs, they can be managed in the same process by running two different threads. So memory consumption also decreases. So how we can create a thread? So there are two ways to create a thread in Java. One is runnable interface, one is thread class. So let us see the skeleton now. So in Java, there is one interface known as runnable. This is like a predefined. So we didn't create, but this is predefined. And it has one method known as run. So there is a predefined class known as thread, which implements runnable. So it means it has to come up and override the method run. So this guy thread class is also having one method known as start, which internally calls the run function. So these are some skeletons for the predefined two structures, runnable and the thread. So how you need to create a thread? So if I want to create a thread, I will say class my thread. Either I will say extends thread or I will say class your thread, which implements runnable. Threads can be created in two different ways, but for both the threads, you need to come up with the method known as public void run. So this is the method which we need to override in both the classes. So either you do extends thread or you do implements runnable. So whatever the task your thread has to perform, all these instructions which your thread has to perform, so they must be written in the, so jobs or instructions for user thread must be written in run method. So jobs or instructions which main thread should execute should be written in the main method. So you can write your jobs or instructions for the main thread in the main method, but you need to come up with the run method for your child threads. So that's how you need to come up and write your code. So just the way you got this class task, now I'll create one class known as my thread which extends thread. So my thread extends thread. Now you need to come up and override this method known as run. So you just say a public void run, and now just the way you got this class task, we got class my thread. The difference, it extends thread, it is not extending anything. The way you got execute task, in a similar way we got a run method, and here I'm going to come up and just mention the guy my thread. So as of now you can see, first of all task is executed and then the main thread is coming into the action. So rather than coming up with the task, now what I'm gonna do, I'm gonna create the object of my thread by saying empty reference assign new my thread, and then you say empty ref dot start. Why you say the start as a function call, not directly the run? Because over here if you can see, the start method internally calls the run method. So here some state management happens. So you need to come up and always call the method start, not the direct method run. So you'll understand the states later, but now when I run the program, there is some different sort of output. Now if you can see what is happening, some instructions of main thread are fused with the instructions of my thread. Anytime you will run the code, you'll always keep on getting some different outputs. So altogether we can understand from this output as both the threads are running parallelly. CPU is performing time slicing. It is giving some time to the main thread, some time to my thread. So we must understand, if you are coming up with a basic class, it's not gonna run parallelly. Threads, they're gonna run parallelly to the main. So CPU is performing time slicing. It's giving some time to main thread, some time to my thread. So overall, in the eyes of user, both these threads, they are running parallelly. So this exactly is our program now. So let us say CPU now. So it's gonna have a frequency of 2 gigahertz. It means time will come up somewhere around 0.5 nanoseconds. Just imagine the time to execute some instruction by the CPU. So half of a nanosecond. So all in all, we must understand that these instructions are executed so quickly that for us, we feel like it is happening in a multiple fashion. But ideally in the background, CPU is performing time slicing. So performance will not be degraded. Performance remains the same, but you are able to come up with the multiple programs executed all together. Now let us try to create one more thread. So I'm gonna create this guy as your thread. So let us say we got a your thread, again with the same story. So it means that creating a thread is very simple and very basic. You just create a class with an extension, and you always have to mention the tasks in the run method. So the way you created my thread, in a similar way I'm gonna come up and I'm gonna create a your thread, and lastly I'll say ytref dot start. Now you got 3 threads. One is main thread, one is your thread, one is my thread. So when I'm gonna run the code now, so you will be able to see mixed output for 3 threads. That threads, they're gonna execute in a parallel fashion. Let us come back and let us try to understand that once we are talking about the multiple threading technique over here, so there can also be a situation that you have a class A and then you got some class B which extends A, and I want B to be a thread. So you can't come and say comma of thread and then you say let us come down with the run method. So if you can see, this is not allowed. Why? Because multi-threading, I mean multiple inheritance is not allowed. So multiple inheritance is not allowed in case of Java. That's why you cannot say class B extends A comma thread. So what is the possible way out? You say implements runnable. This is how you can come up with the multiple threading in case you are already inheriting one class. Over here, so we can see now why we need runnable. So you can write your threads by saying a class like rthread which implements runnable. But internal structure that remains the same. So it hardly matters. So let us say rthread like this. So we got my thread, your thread, and our thread which implements runnable. There is one difference if you are having a thread which is going to be from the runnable, how you will create it. So first of all, you write runnable r assign new of r thread. So that's like polymorphic statement. The next part is you say thread ot reference assign new thread and you pass the runnable. And now you can come down and you can say otref dot start. So my thread, your thread, and our thread into the action. You need to come up with a polymorphic statement and you need to create the object of a regular thread, but in the constructor of the regular thread, you pass the reference of our thread. Now when you run the code, you get 4 threads in action. If you can see now, there are 4 different threads coming into the action. So my thread, your thread, our thread, and the main thread. All running parallelly. You can see now all of them are running in parallel operation. So for a class which implements runnable, you cannot directly create the objects and say the start. You need to write the polymorphic statement, create an object of thread and pass the reference of your thread which implements runnable. So creation of objects for the rthread class is a bit different from a regular class which extends the thread. So here you are not coming up with the exact thread. So exact thread is constructed below. So now I'm going to write one instruction. Let us see that. So in the main method, I'm just gonna say thread dot sleep for 1000. This is like making the thread to be blocked for 1 second. You are going to block the thread for 1 second. Now when you say thread.sleep, so thread is a predefined class and sleep is its static method. So it is giving us an error. So because sleep method will throw a checked exception. So compiler is prompting us to put this code in the try catch block. So what is this sleep guy all about? So sleep is all about where you can see that after every 1 second your same thread is coming up. Let's run the code again and see the output now. So sleep is one such command which makes your thread to block for 1 particular second or any time duration which you want to put in. For example, I'm going in the other loops and I'm going to put it for 500 millisecond. Let us say 250 and let us say we'll put it for 750. So guys, I'm just making all the threads to sleep for some of the time durations and let us see. So there is a bit of a blocking for the threads. Let me run the code again. So you can make your threads to be blocked for some time and then after some time they can resume off. Now the way you got sleep, we can try to come up and settle the priorities of our threads. So what I can do, I can say empty ref dot set the priority thread dot max priority. Similarly, I can say otref dot set the priority. Let us say minimum priority, and here I'm gonna say some normal priority. Let us say YT and OT. So you can set the priority of a thread to the max, to the min, or to the normal. So max means the integer number 10, minimum means 1, and normal means 5. So that's how you got the priorities for the threads to be settled. So how we can come down and see the priority for these guys? You can see, so empty ref priority is plus empty ref dot get the priority. I'm getting the priority for all the threads. You say YT as well as OT. Let us also try to get the priority of the main thread. You say main thread priority. So to get the priority of a main thread, you don't have the reference to the main thread. You say thread dot current thread dot get the priority. So we are getting the priority of the main thread by getting the reference to the current thread and then calling the get priority method. When you run the code now, you find over here the outputs are not predictable by us somehow, but let us see the priorities coming into the action now. So here you can see the empty ref priority is 10, YT is 1, OT is 5, and main thread priority is 5. So by default, all the threads, they have a normal priority which is 5. So if you don't come up and set the priority to any thread, so the default priority is all 5. Let this output get finished. So here you are. Setting the priority does not mean that your threads will be executed in a different order. So setting priority is a request. It might be fulfilled, it might not be. So that's how you should be able to understand priority is something which might be fulfilled or might not be. Sleep is a command. So this guy is a command. It means that it has to be done, it has to happen. But this guy is priority, which is a request, not a command. Similarly, you can also get the names of the threads. So you say name is, so you now just come up with this guy known as get name. So just call the method get name and you will be able to get the name of your threads. We'll just have a look onto the names. So you can see that the names of your threads are coming out over here as thread 0, thread 1, thread 2, and the main. It means that empty ref, YT ref, and OT ref, they have some default names like thread 0, thread 1, and thread 2. So if you want to come up and change the names, so that is again very simple. So you say empty ref dot set the name. You can say my thread, then YT, OT, and then you can also change the name of your main thread by saying thread dot current thread. So you can say your thread, you can say our thread, and you can say, for example, my main thread. Now when you will run the code, you will find that the names of your threads will be changed from the default to the one you have kept. Let the output get finished. So these are what? The names of your threads. So setting of the name, setting of the priority. So these are some basic operations which we have seen. Now what I'm going to do, I'm just after empty ref is started, I'm going to call one method known as empty ref dot join. Join will also throw an exception. You need to put it in the try catch block. Just exactly after empty ref dot start, we are executing empty ref dot join. Let us see what this guy will do. Now you can see the output says that let us execute all the instructions of my thread and later we will execute the other threads. So join is a command which once you kept on a thread, so all its tasks will be executed and all other threads will wait for this thread to finish off. So coming back, join is a command again, which means this will be executed, all the other threads will wait. But you cannot come this guy over here. You can't say, let us put the join on the empty ref after all the threads are started. No. So you need to come up with the join method call before you start a thread. And if you come up and if you put the join with ytref like this over here, so coming here, I'm just gonna say ytref.join. It means that now what will happen? Initially, the tasks of my thread will be executed. All other threads are waiting. Now your thread will start off. All other threads will wait. So remaining threads, they're gonna run in the parallel operation. So just the way you got join, the opposite of join is known as yield. We also have a guy known as yield. So yield says that do not execute my tasks, but execute the tasks of others. But it is a request again now. It might be fulfilled, it might not be. So yield says that do not execute my tasks, execute the tasks of the other threads. So that's what we got as in yield as a method call. We got threads as in the normal threads, as in the threads which can be created through Runnable. For Runnable, you need to come down and you need to write a polymorphic statement with the thread. Whereas your threads can have the priorities, they can have the names, you can set the priority, you can get the priority, you can set the name, you can get the name. You can join a thread so that all the tasks of your thread, they will be executed. But here you need to come into this point that join should happen immediately after the start. I'll write this: immediately after the start, we are executing the join. Multi-threading in Java can happen in two ways, either by extending a thread or implementing a Runnable. So extending a thread, you need to come up with extends thread and you write the code in the run method. Implementing the Runnable, again you override the run method. So why you need Runnable? Because multiple inheritance is not supported in Java, so you can come up with implements Runnable. Otherwise you come up with extends thread somehow. So there are many constructors for the thread classes now, and thread has one life cycle. New means a new object of the thread is created. Runnable means you have invoked the start method. It means thread will go into a state where it can start running. So running is a state where your run method is executed. Blocked can be a state where your thread is sleeping for some time and at that time nothing is happening. So this is a kind of a state known as a blocked state. Terminated means when the run method is finished and the thread has done its part, so it will not run again. So that's like the terminated state. So these are known as the states of the life cycle of a thread. So we do have a life cycle in some representation. So a new state, a runnable state, then terminated. So it can be a timed waiting or it can be a waiting. So blocking state can be timed waiting. For example, we are waiting for some 1000 milliseconds, or you are just waiting for unlimited time. So let's see one more example over here. So I'm just gonna write one new Java project. So I'm gonna write one new class. So that goes like table. So that's like one class. Or let us just write the class known as syncdemo with the main method. Let us say com.rebss. What I'll do, I'll write one class known as table. So table has one method known as print table. So this is one method known as print table, which takes one input as a number for which I want to print the table, and I'm gonna iterate it for int I equal to 1, I less than equal to 10, and I plus plus. So you say CISO num plus i's are num into I. That's what you got as in the table of a number. So anytime if now I want, I can just create the object of the table. I can say table t assign new table, and thereafter I can say t dot print the table of 5, and what I'll get an output. So here is the output. So if you want an output with a bit of delay, you can also do so by saying thread dot sleep, and you can just mention the sleep cycle of, let us say, 200 milliseconds. So when you send a request for a sleep, you must surround it with the try catch block because it's a checked exception. So sleep throws a checked exception. That's why compiler will prompt you. So now when I'm going to run the code, I can find the table of 5 coming in this fashion. So what I need to do, I need to understand that this guy t is a reference variable which points to an object. So t holds the address now. For table, I have only one object. So I'll just write down. For table, we have only one object which is referred by t. Now this is really important to understand. We got only one single object which is referred by t. So what we need to do next, so I don't want printing of the table to be happening by the main method. I want this to be done by a thread. So this should be done by a thread. So printing of table, let us do it by thread. So in order to come up with the threading part, you just come down and you say a class. So let us say we got this guy as my thread, which is going to extend the thread. So my thread will be responsible to basically execute this guy, t.printTable. So I want this t.printTable to be executed by my thread. So how it can be done? I will declare table t over here also. I'm going to come up with table t. So I'll say one constructor out here with the my thread, which takes the input as table, let us say u. It's as simple as that to understand that we got my thread. The constructor of my thread is taking one table u as an input, and this u I am going to assign it to t. And in the run method, I'll say t dot print the table of 5. Let us now come down and let us create the object of my thread. Let us say empty ref assign new my thread, and you are going to pass the guy t. So the reference of t, whatever the address of the object is there in the t, is copied in the u, and then you assign u to the t. So it means t.printTable over here is using the same object, and thereafter what I can do, I can say empty ref dot start. So when I will start off my thread, you'll get the same output somehow, but my consideration over here is that my thread is using the object of table. My thread is using the same object of table which we created in the main. So guys, now when I'm running the code, you can see that you are getting the same output. But what I want one more thread. So let us write one more class and let us name it like your thread. Your thread is also doing the similar task, but it's gonna perform it on number 7. So now I will create an object of your thread. Your thread is also taking the input, that is like your t parts, right? If you can see now, this guy is also taking the same input t. So it means we got my thread and your thread which are going to work on a single object. Now ultimately we can come up and understand over here your thread is using the same object of table which we created in the main. It means that we got a single object. For table we have only one object which is used by my thread and your thread. This is what the complete instruction becomes now. The single object is used by two threads. So it means that we got a condition where two threads, they are working on the same objects. So two threads are working on the same object. Two threads are working on the same object, so they are sharing the same object which is pointed by t. Now when I'm going to run the code, you might see some mixed output if you can see out there. Let us increase the speed and then try to check what is happening over here. And let us now run the code. What is the observation over here? The observation is the tasks over here, they are quite mixed off, right? Now, why they are mixed off? Because the threads, they run parallelly. Now, since threads run parallelly or concurrently, so we are getting time slicing in action. So what is this time slicing in action? So when I say time slicing in action, so if you can see that sometimes instruction for my thread comes up, sometimes for your thread. So even though let us consider that there is no time slicing, I mean there is no sleep coming into the action. Let us say there is no sleep now. You run it directly, you will see the execution behavior. It is mixed output. So we are not considering the mixed output. So our fundamental is not to understand that we are getting the mixed output. We must understand fundamentally two threads are running parallelly and we are getting time slicing in action and they are consuming the same object. So multiple threads running at the same time are using the same single object. So what has to be done in this regard? So consider that you are in bookmyshow.com and you need to book a movie ticket or you need to book any ticket, any seat. So if there are two people who are going to target one single seat, so when one person will click on the seat which he wants to book over the online portal, so once he click on the seat, that seat will be blocked for him for some time interval. When a particular seat is blocked, no other thread can view that seat as an available seat. So here I am talking about I want my threads to acquire the lock the moment they execute print table method. I want my thread to acquire a lock on the print table method so that whenever a thread is executing the print table method, no other thread should execute the print table method. As of now, if you can see both the threads, they are using the print table method of the same object. So now what I will do, I will mark this guy as synchronized. When you mark your method as synchronized, there will be race between these two threads that whosoever is gonna start first, he will come up with the call of print table, and now the print table, when it's gonna start execute, it will acquire a lock. It means since the print table is in execution, no other thread can execute this method until the method is finished. So lock is acquired implicitly when the control enters into the print table. When the control exits the print table, lock is released. Lock acquisition happens. So this lock is also known as, either you can say lock or monitor or mutex. You can use these terminologies somehow, where mutex means mutual exclusion. So coming up now as in execution part, you can see the output is very much aligned. So when one thread is working, no other thread is able to work. So let us come up and remove this sleep even. So you can see that when thread of 5 is working, no other thread can access the print table method. So at the same time, if this guy is marked as non-synchronized, both the threads, they are going to execute the print table method. Whatever you can see as in output, you can see over here, you are getting the mixed outputs coming out over here. So that's what we call him as in asynchronous part, and this is known as the synchronous execution. In the synchronization, your threads are waiting for other threads to release the lock so that they can acquire it and they can work it. Whereas in case of a normal execution, you got the asynchronous fundamental. So why I am making it as of now asynchronous is to understand one more concept. There might be a situation that you have n number of methods in your class, and practically speaking, it's not
very relevant to make all n number of methods as synchronized. For example, you got a void fun. You need to make this method also synchronized if you want to make it thread safe. So thread safety, where only one thread is gonna work, other threads gonna wait. Now n number of methods in your class. So for synchronization, you need to make methods synchronized. So that's like you need to come up yourself and identify which and all methods you are supposed to make as synchronized. So this is one limitation now, that if you have 10 methods, you need to come up and you need to make 10 methods as synchronized so that your fundamental can go synchronous. Now what I can do, rather than writing that part, I will just come up over here and I will say a synchronized block, and I will pass this guy t, and I will say t dot print table of 5. So you can see now I created one synchronized block, rather coming up with the methods as synchronized. Now what's gonna happen? So the same way both the threads will start. Whosoever will start first, it's gonna acquire the lock over the t itself. So you say acquire lock over the object to which t points. So that is what we got as in term synchronized block. So lock will be acquired for the time of your synchronized block. It means that you can come up and you can also call t dot fun. So let us try to say so this is fun. So guys, lock acquisition over here, when I'm going to run the code now, we'll understand one part over here. So you can see now this is fun is coming out, and after that the 7 table is getting printed. It means that lock acquisition remains for the entire block over t. So what is this definition now? No other thread can use anything over t until the block is finished. Now this is something more relevant and more great as compared to the previous one. The next thing which we need to understand is, let us say I got one attribute as long L assign 100. So I'm gonna mark this method as synchronized, but an attribute cannot be. So an attribute can be marked as volatile. It means when a write operation happens on L, no one else can read or write. So it's like again a locking. Volatile is a keyword where it will ensure atomicity. So volatile ensures atomicity. What does this mean now? So it means that consider we got 64-bit container. What is L? L is a 64-bit container. So let us say OS is 32 bits. So write operation in L will happen in two shots of 32-bit each now. So when you're gonna come up with the L, you need to write the data into the L with the OS of 32 bits. So you'll be writing 32 bits and 32 bits. So it might be a situation that one thread will write the data only 32 bits and the remaining 32 bits is not written, but the other guy read that data. So you can mark your variable L as volatile and you can ensure atomicity or the synchronization concept. Other than this, we got a complete package known as java.concurrent, which is based on threads synchronization. So you can come down and you can explore this package now. Just for an example, we got a class known as atomic integer. If you can see from the concurrent package, you got this guy like atomic integer. So we got various APIs available in Java which ensures atomicity or concurrency, that is like thread safety. So you can come up with that part. For synchronization, until the task is not finished, no other task can be executed. Theoretically speaking, there are some different types of locks. Fundamentally, we have just discussed only one basic intrinsic lock, that's like implicit locking. Locking happens automatically. You don't care about the locks. So you don't write the locks yourself. Lock acquisition happens automatically.
So we got fat locks. When you are going to acquire a lock, so there will be the history of how many locks have been acquired before. Thin locks will have no history of contention. Contention means locking. So recursive lock means that a lock has to be acquired by thread again and again several times without releasing of the lock. So I'm acquiring the lock again and again. Lazy lock is a lock which is not released when the task is finished. So it means that the lock release has not been ensured, and obviously even though the task is done, the other guy cannot perform the task. So these are some various locks, and one is the situation known as deadlocking. So there might be a state where multiple threads, they are blocked waiting for each other to release the resource. So there might be my thread 1 waiting for my thread 2 to release this guy, and other guy is waiting on one more resource. So having this state means that this is a problem with the developer's algorithm or developer's logic somehow. So one more example on what is meant by thread synchronization. Thread synchronization, where let us say we got multiple computers, they're gonna request a single printer now. So when the printer's gonna print the data from these 4 different computers, so he has to print in a synchronous way. So when the printer is printing document from one request, it cannot entertain at the same time to the other request. So that's how you got the concept of server as well. So server is like when it is handling or processing one client, it cannot process the other client at the same time. You need to wait to get your turn somehow. So when 2 or more threads, they try to access the same resource simultaneously, so Java runtime can execute one or more threads more slowly, or even it can suspend the execution. I will take one more example over here now. So let us say a new class with the main method. So I'm gonna create one class known as message, which has this string message, and you got a constructor which says message assign no message available. So we got a function known as a write message, which is supposed to say one message, let us say be exceptional. We got this message like be exceptional, after which I'm gonna say message return, and then you say void read the message. So I'm going to come up with CISO messages plus the message. When I came up with this structure of message now, so what we have the default value has no message available. Write message will write the data, message return, and read message will read the data. So now I'm going to come in the main method. I'll create a message m assign new of message. So I say m dot write message, so m dot read message. So if you read the message before you write the message, you will get no message available, and then you can see that you are doing a write on the message. I'm just gonna say message assign be exceptional. It says no message available, and then it says message written. But if you do a write operation over the object of m before the read operation, you will see that message is written before, and then the message becomes as be exceptional. Over here we must understand write and read of message. If you don't write, let's say read before write, you get the default value. So that's what you are coming up with. Now what I want the read write to happen 2 different threads. Let us understand. I'm going to create one class known as a reader thread, which is going to extend the thread, and reader thread has to come up and read the message. So for that, what I'll do, I'll create a constructor of reader thread, and I will say that let us pass the message some n, and let us write this guy message m, and then you say m assign n. In my run method over here, so I will make a synchronous call. I'll say synchronous m, you say m dot read the message. So reader thread is working on the guy m,
to perform read message but in a synchronous function. It means that if reader thread will be reading the message, no other thread can write the message. So similar to the reader thread, I'm going to come up with one more thread. So I will name this guy as a writer thread. So writer thread has a job not to read the message but to write the message. One thread is reading the message, other thread is writing the message. So I'm going to come up and create both the threads. So I'm going to say reader thread rt1 assign new reader thread, which takes the input as m. Similarly, you say writer thread, let us say wt assign new writer thread, and you pass the guy m. So it means a reader thread and a writer thread, they are again working on the same object. So reader thread and a writer thread are working on the same object of M, but in a synchronous way. So that is also important. So they are working on the same object of M as in the previous example we understood, but they are working in a synchronous way, if you can see. So what I'll do rt dot start and then wt dot start. So most chances that RT will be executed before the WT, they exist because you are starting the RT before the WT. Now when I run the code, you find that reader thread came up before the writer thread. What is expected? The expectation is when the reader thread starts, so what it should do, it should say please wait in order to perform any operation on M. This wait is also supposed to be surrounded with the try catch block. You can see we have got this m.wait executed on this guy. Now if a reader thread will start its execution over the m, since it will not give the lock to anyone else, so what we'll do, we'll make this guy to wait. So when this reader thread is waiting, lock will be released for other threads who wants to work on M. So when you say m.wait, so here the lock will be released and the below statements will not be executed. So below statements are not executed after the wait on M. So control comes to the writer thread now. So writer thread writes the message. After writing the message, you say m.notify. So notify notifies the thread waiting on M to resume its execution and acquire the lock. This is the whole story now. So what we have done, we have came up with the reader thread and writer thread. We wanted reader thread to wait before writer thread will do the right job. So that's why the moment this guy acquire the lock, we tell them to wait. Since this guy is waiting, lock will be released for the other thread who wants to work on M. That is like the writer thread, because you can see now both reader and writer, they are working on the M, and M points to the same object. So writer thread will come into action. It's going to write the data into the object of M. Then it's going to call notify. Notify means this guy was waiting. Now the wait is over. So below written statements which were not executed, now this guy will execute it. So now when I run my code, you find that before your thread's gonna read, it's gonna wait. Your message will be written and you will be getting a proper message as in output. Considering now if you got RT1 as well as RT2, so we got two reader threads coming into the action now. So I'm gonna start both the threads RT1 and RT2. You will find that if both the threads are started, so both of them, they are supposed to wait. When I say wt.start after the RT1 and RT2, it means two threads are in the wait state. When two threads are in the wait state, your wt over here will perform the action, and now he will not say notify, but he will say m.notify all. Previously you were getting only a single output, so notify all notifies all the threads waiting on M. Now you can see you get two outputs for the same read operation. Previously, you were getting only one output. So notify notifies the single resource, whereas notify all will notify all the threads waiting. Thank you very much.